The site visit to Jabatan Mineral Geoscience Sarawak conducted by Group 17 aimed at gaining first-hand knowledge of natural mineral and materials, including rocks, minerals, and fossils. The visit was carried out by the staff at Jabatan Mineral Geoscience Sarawak itself with the objective to evaluate the formation processes of rock, mineral, and fossil, understand the distinctive characteristics and properties of each type, investigate their geological origins and distribution, and gain insight into their significance in geological studies. This information gathered will enhance our knowledge and appreciation of Earth's natural resources and their role in shaping the planet's history and ecosystem. Igneous rock form from the cooling and solidification of magma or lava. Magma is a molten rock beneath the Earth's surface, while lava is a magma that reaches the surface. There are two types of igneous rock, which is intrusive rock and extrusive rock. Intrusive rock, which form below the surface from slow cooling magma, have a coarse grain texture. Granite is a prime example of this type. Extrusive rocks form on or near the surface from rapidly cooling lava, resulting in a fine grain texture like basalt. The cooling rate determines the texture and appearance of this rock. Due to their durability and attractive appearance, igneous rock are commonly used in building monuments and countertops. Moreover, diorite was widely utilized by ancient civilizations for crafting vases and other decorative artworks, and it continues to be used in art today. Sedimentary rocks form from the deposition and solidification of minerals and organic particles transported by the water, wind, or ice. These rocks are classified into three types: clastic sedimentary rocks, like sandstone and shale, form from mechanical weathering debris. Chemical sedimentary rocks, such as limestone and gypsum, form from mineral precipitations. Organic sedimentary rocks, like coal, form from plants or animal debris, like often exhibit layering and may contain fossils. Sedimentary rocks are generally softer and may show porosity and permeability. They are widely used in construction, particularly sandstone, which is valued for its durability and ease of workability, making it a popular building material in regions where it is abundant. Metamorphic rock form when sedimentary or igneous rock transform under high pressure and temperature. This process, known as metamorphism, alters the mineral compositions and structure of the rock without melting it. Metamorphic rock are classified into two main categories. First, foliated metamorphic rock, like schist and gneiss, have a layered or banded appearance due to mineral alignment under a directional pressure. Non-foliated metamorphic rock, such as marble and quartzite, lack this banded texture and have more uniform structure. In construction, metamorphic rock like granite, gneiss, and quartzites are strong and durable, making them excellent building material due to their resistance to weathering, fire, and wear.
Rocks are naturally formed solid masses that make up the Earth's crust and mantle. They consist of minerals or mineral-like substances and occur in various shapes and locations on Earth and other celestial bodies. There are three types of rock based on their formation. Metallic minerals are natural deposits containing metals valued for their conductivity, ductility, and malleability. Formed through the heating and cooling of igneous rocks, they exhibit complex structures and shiny surfaces. These minerals are indispensable in semiconductor manufacturing, electronics, and jewelry. Examples include iron, gold, copper, manganese, and bauxite. Specific applications include silicon extracted from quartz for computer components and aluminum derived from bauxite for bottling and automotive manufacturing. Non-metallic minerals form from sedimentary rocks over time, incorporating various particles, minerals, and organic matter. They are vital in industries supplying materials for coatings, insulation, cement, and fertilizers. Examples include salt, phosphate, limestone, mica, dolomite, coal, gypsum, manganese, and granite, each serving specific roles like salt for food and industry, phosphate for fertilizers, limestone for cement, and coal for energy. Precious minerals like gold, silver, and platinum are rare metallic elements valued for their economic worth and unique chemical properties. Known for their durability, scarcity, and cultural appeal, they exhibit low reactivity and ensure stability in electronics, jewelry, and catalytic converters. Historically, symbols of wealth and power, they now primarily serve as stable investment commodities, playing an essential role in modern technological advancements across industries. Macrofossils or megafossils are visible remains of organisms and their activities that can be seen without magnification, unlike microfossils which need magnification for examination. They make up the majority of fossils found in the field and collected specimens, encompassing remnants of plants, fungi, and animals. These fossils are formed through diverse environmental processes that influence their preservation over time. Microfossils are tiny remains of bacteria, protists, fungi, animals, and plants preserved in rocks, requiring specialized techniques and microscopes for extraction and study due to their size. Examples include stromatolites, which is ancient bacteria, foraminiferates used in environmental reconstruction, diatom frustules, indicative of past aquatic conditions, small shells like ostracods and radiolaria, pollen grains, and tiny vertebrate bones and teeth. They are crucial in industries such as oil exploration, mining, engineering, and environmental sciences for age determination and reconstructing ancient environments. Trace fossils are preserved signs of biological activity by organisms such as feeding, scratching, burrowing, walking, or resting. They manifest as tubes, lines, or scratches with distinct features suggesting their origin from living organisms like animals, plants, protists, and bacteria. Occasionally, specific groups responsible can be identified, such as dinosaur footprints or shrimp burrows.
In Sarawak, an example of an igneous rock is basalt. This rock is typically dark gray to black and primarily composed of plagioclase, feldspar, and pyroxene. Basalt has a fine grain of aphanitic texture, indicating rapid cooling of lava or magma. When weathered, it often develops a reddish rim due to the oxidation of iron-rich mineral. Known for its strength and durability, basalt lacks bedding, plants, and fossils, and has a dull to vitreous luster. It formed from solidified lava flow or magma intrusion. A similar rock is andesite, which also has a fine-grained texture and comparable mineral composition. Sandstone is a notable sedimentary rock. This rock varies in color, often appearing tan, brown, or red, and is primarily composed of quartz and feldspar, with occasional clay mineral. Sandstone typically exhibit well-bedded structure with distinct layers. When weathered, it forms rounded grain. Its strength is variable, ranging from moderate to strong, and it is usually medium to coarse-grained, sometimes containing fossils. Sandstone has well-developed bedding planes and generally dull luster. It's formed from a consolidation of sand-sized grain deposited by water or wind. A similar rock is conglomerate, which also has rounded grain but is larger in size. In Sarawak, Slate is an example of a metamorphic rock. Typically dark gray, black, or green, slate is mainly composed of fine grained mica, quartz, and occasionally graphite. It has a foliated texture with very fine graded parallel layer, allowing it to split easily into thin sheets along these plates. Slate is relatively strong and durable, fine-grained and lack fossil. While it is exhibit distinct foliation, it does not have true bedding planes and has a dull to slightly shining luster. Slate form from the metamorphism of shell or mudstone under low-grade condition. A similar rock is finelite, which has a slightly higher degree of metamorphism and a fine-graded texture.
By identifying some key minerals and their properties, followed by a look at various fossils and what they tell us about the past. Let's begin with mineral identification. Minerals are classified based on their physical and chemical properties. Here are some examples. First, we have bornite, a sulfide mineral. It is a sulfide mineral and its habit is massive and granular. The cleavage is poor in three conditions. The color is metallic copper red, tarnishes to iridescent colors. The luster is metallic. The hardness is 3.0. The specific gravity is 4.9 to 5.3. It is also known as peacock ore due to its vibrant tarnished colors. Next, we have quartz, a silicate mineral. The habit is hexagonal prisms, the cleavage is none, and the color is colorless but can vary with impurities. The luster is vitreous, hardness is 7.0, specific gravity is 2.65, and quartz has a conchoidal fracture and is abundant, often used in gemstone. Now, let's look at muscovite, a phyllosilicate mineral. Its habit is tabular and micaceous. The cleavage is perfect basal cleavage. The color is colorless, white, silver, or light colors. The luster is pearly to vitreous. The hardness is 2.0 to 2.5. The specific gravity is 2.76 to 3.0. It is also known as mica. Muscovite is used in insulator. Thank you. Moving on to the fossil identifications, fossils provide valuable insights into ancient life and environments. Here are some examples. Our first fossil example is fossil leaves from the Dipterocarp species. It is located at KM 28 Jalan Selangor, Mukah, Malaysia. The age is Upper Miocene 11.6 to 5.3 million years ago. It is found in paleo environment, tropical rainforest, and it is the elongated leaves with a prominent midrib and parallel secondary vines. Next, we have a fossil fern from the Wilsmia genus. It is located at coast of BC, Canada. The age is Middle Jurassic, 174 to 163 million years ago, and it is from paleo environment, humid, swampy environments, and it is finely divided fronds with symmetrical pinnacles. Here we have a sharp-toothed fossil from the Carcharodon species. It is located at mile 68 Bintulu to Miri. The age is Miocene 23 to 5.3 million years ago. It is paleo environment, marine coastal waters, and it is large, triangular, serrated teeth shape. Finally, let's look at the dinosaur bone fossil. It is located at Canada. The age is Jurassic 201 to 148 million years ago. It is paleo environment, varied forest, floodplains, semi-arid regions, and it is well-preserved bone structures, possibly from sauropods or theropods.
Minerals form through various geological processes such as crystallization of magma, changes in temperature and pressure, and precipitation from solution. These processes is called as mode of formation. Different type of rock undergo different mode of formation. Occurrence of a mineral or rock refers to its presence in a specific geological setting or location. Occurrence tells how is the distribution of minerals within the earth crust and the geological conditions that affect their formation. There are four main categories of mode of formation, which are igneous, metamorphic, sedimentary, and hydrothermal. Igneous rocks form through the cooling and solidification of magma. The formation of igneous rocks can be categorized into two types, which are intrusive plutonic and extrusive volcanic. depending upon where the molten rocks. Intrusive igneous rocks form when magma is trapped deep inside the earth. On the other hand, extrusive igneous rocks can be found above the earth's surface. Igneous rocks are found at divergent and convergent plate boundaries, hotspots, and continental reefs. Metamorphic rocks are produced from pre-existing igneous, sedimentary, or other metamorphic rocks by changes in temperature, pressure, or the action of hot mineral-rich fluids. In metamorphic rock formation, high pressure can cause rocks to deform plastically, leading to the development of foliation and reorientation of mineral grains. Metamorphic rocks commonly occur in mountain ranges, cratons, and shields, and at mid-ocean ridges and subduction zones due to hydrothermal and high-pressure, low-temperature conditions. Sedimentation comes from pieces of once living organisms or pre-existing rocks. If sediments that accumulate on the Earth's surface is buried deeply, it becomes compacted and cemented. The formation process of sedimentary rocks involves several stages, including weathering and erosion, transportation, deposition, and lithification. Usually, sedimentary rocks can be found in fluvial area, lakes, desert, marine, glacial environment, and swamp and marshes. Hydrothermal can be defined as the action of water and other solvents under high temperature and pressure conditions that causes changes in the earth's crust and that result in formation of rocks, minerals, crystals, and ores. As water is heated by magnetic activity, the minerals from surrounding rocks can be dissolved due to the increased solubility at higher temperature and pressure. The hydrothermal fluids now, enriched with dissolved minerals, move through the crust along fractures, faults, and porous rocks driven by pressure difference, buoyancy, and sometimes by the force of the geothermal gradient. Hydrothermal deposits occur in various geological settings where hot, mineral-rich fluids interact with rocks under high temperature and pressure.
Diamond and graphite are carbon allotropes with giant covalent structures. Diamond is prized for its hardness and brilliance, making it popular in jewelry. Graphite is known for its lubricity and layered composition and is widely used for its electrical conductivity, high melting point, and thermal stability in applications like batteries, electrical contacts, and high temperature metal casting molds.
In conclusion, this technical report gives a thorough summary of nearby geological materials, including 6 types of rocks, 3 types of minerals, and 3 types of fossils. It includes details about the qualities, attributes, structure, and presence of every sample. This report additionally contains a comparison to emphasize similarities, possible confusion with other samples, and practical uses of the materials. By going to the site visit and doing this technical report, our knowledge and comprehension of this topic increases. Thank you.